Hey everybody, it's Professor Ross, and in this short video we're going to be talking about one of our main mathematical tools that we use in statistics, probability, and some of the important ideas about whenever we talk about probability. So I'm going to share my PowerPoint here, and we're going to be talking about probability and assumptions. So let's take a look at a couple of probabilities. We've already explored a few ideas about probability. Probability is the likelihood of an event occurring. And here are a couple of examples. The probability of choosing a goat behind a door, probability of rain tomorrow, the probability of rolling a 2 on a die. I'm going to encourage you to pause the video for a moment and see if you can write down a percent chance, a probability for each of those three. All right, so you've tried to give an approximate probability for each of those. Don't forget, probabilities are always between 0 and 100%, or if we write them as a decimal, 0 and 1.0. Let's talk a little bit more about what these probabilities might be and how important the idea of assumptions are. So probability is the likelihood of an event occurring, but it always depends on what assumptions we're making. For example, the probability of choosing a goat behind a door is 66.6% approximately. Under what assumption? Assuming there are 3 doors and 2 of them have goats behind them. Monty Hall might have chosen one day to only have 1 door have goats behind them, and that would be a different probability. Or no goats that day, maybe he had donkeys. That would change the probability again. So that assumption comes in to be really important when we're trying to talk about what that probability is. Probability of rain tomorrow is, maybe you looked that up, Googled the weather, but assuming we're talking about, let's say, Maryville, Tennessee, what if we were talking about Reno, Nevada? Probably a different chance of rain there. Or Seattle, Washington? Probably a different chance of rain there. So once again, really big, important assumption that can change what the probability is. Or the probability of rolling a 2 on a die is 16.6%, assuming you're rolling a 6-sided die with a single 2 on it. Many other types of dice exist. If you like to play board games like I do, or role-playing games, a dice like this with 20 sides doesn't look that strange to you. And there are lots of different kinds of dice out there. What kind of die you're using changes the probability of rolling a 2. So the key point here is that these assumptions really make a difference, and best practice is to be really clear about your assumptions. So you always want to say, assuming this is the case, then here's what the probability is. Since probability is a key tool in statistical inference, it's going to be really important for you to be clear about your assumptions whenever you're talking about probabilities. One of the main probabilities that we will focus on is what's called a p-value. In any statistical scenario, you're gathering some information, gathering data. The p-value is simply telling us about the probability that we would see the results we ended up actually seeing in our data, assuming that one of our hypotheses that we call the null hypothesis was the true hypothesis. Now, we haven't really talked about hypotheses much. We'll get more into that. But the key idea for us in this whole video is to pay attention to this idea that we actually have something we're assuming whenever we talk about a probability. And if you're not being clear about what you're assuming, your probability is not really that meaningful to talk about. So that's the encouragement whenever we talk about probabilities, and especially in this course, talking about p-values, always make sure you're paying attention to explicitly talking about what you're assuming.